Okay, so we're talking about forms of an equation. We're reviewing for this big quadratics test on Friday, and these three forms are the main forms you need. General form, which is this one. I took a bunch of ACT tests over break, just because I really want to do a good job of preparing you for those ACT tests. And so I noticed that this kind of equation is on there a lot. We almost never see this one on the ACT, but we see this one on there a lot too. They like factoring on the ACT test. So what's this one good for anyway? Vertex form. Well, it obviously tells you the what? The vertex. And what's the vertex good for? It's the main spot. It's the only special point on a parabola. All these points, I'm sure their mother told them they were special, but they really weren't, except this one. That one was special. Why? Because it's the only spot out of unlimited points on a parabola, because it keeps going forever. That's the only spot where it makes the turn. Okay, that vertex is important. And so a lot of times on real world problems, it's like, where did the submarine finally hit the lowest point? Or what was the ball's height when it reached its maximum? That point is important. So yeah, vertex form is kind of important. All right, let's move on to how do you get vertex form? This is general form. How can you get it to vertex form? All right, I'm going to do one, and then I'm going to have you do one. Do you remember this process? Yes, halfnsquare is going to help. It's called something to something. Starts with the word complete. Completing the square. That's how you do it. So how do I do it actually? I move this 11 over to make room for the halfnsquare thing. Half of 6 is 3, 3 squared is 9, and 9, and one's plus 9, and one's minus 9. And then you remember how this part right here is perfect because you can make two identical things up. And then this part right here is the final answer at the end. And that's the, in this case, plus 2. And these two guys can go together and make x minus 3 quantity squared, and then put a plus 2 at the end. There we go. I just made it into vertex form. Do you remember that process? Yes, sir. Good question. The vertex on this would be 3 comma 2. Notice it's the opposite of what you see in there. It's counterintuitive. That all makes sense. So yes, it would be positive 3, positive 2. It would be like right there. And it would go like that. Make sense? Okay. I want you to all try one. Try that one. Move the 5 way over. Do halfnsquare. Then billboard the answer to me. Turn it my way when you are done so that I can see. And keep it there so that I know who hasn't answered yet. I'll pause for a moment while you try to figure this out. Here's what you should have done. You should have moved the 5 over like this. You should have said opposite, no, half of 6, 3, 3 squared, 9, and 9 plus minus. This part's perfect. Y equals x plus 3 quantity squared. That part right there goes together. Minus 4. Raise your hand if you have that one right. All right, good. Now, that's completing the square, and that's how you get vertex form. But we're not going to tell you how to do it on the test. It's just going to say, get it into vertex form. You got to know that that means complete the square. So there's some words that go together that maybe you should write down in notes. You should maybe say vertex complete square. Because anytime they say vertex, it is amazing how many kids are like, well, what am I supposed to do on this one again? I'm not going to tell you on the test. I'm not going to tell you, oh, just complete the square. You have to know that vertex form is saying you should complete the square. All right. How do you get vertex form if it's like this? Well, what's different? The 2. The 2 makes it different. Well, first thing you should do is factor out the 2. So I'm going to do this one. You can watch. 2 comes out, x squared plus 4x. Notice minus 1 goes to the very end still. Then I leave room for halfnsquare. Don't do halfnsquare at the beginning. You wait till you take the 2 out. Now I do halfnsquare. Half of 4 is 2. 2 squared is 4. And negative 4. And then this is that moment where a lot of people screw up because they forget something. Do you remember what it is that you got to remember not to forget? Yes?
2 is negative 4.
Yes, this 2 right here has to also get multiplied by that. Why? Because this 2 is going to magnify the value of that 4. So we need to magnify the value of that 4 to cancel it out. Final answer, y equals 2, and then x plus 2 squared, and then this part's negative 8 minus 1 makes negative 9. Raise your hand if you think you can handle that kind. And that's most of you. Now let's prove it. Do it. Factor out the 5. Find me vertex form for that. I'm going to pause for a moment. Oh, question? Yes? If that 5 would not factor, and the reason it wouldn't factor is only if that didn't have a 5 in it, we weren't going to give you any of that kind, but that would mean that your answer just comes out to a nasty decimal. It could still factor a 5 out of anything. It just gets really weird. So like if this was a 2 here, I can still factor a 5 out because technically I'm dividing by 5. So then you'd have 2/5. But we're not going to give you any really nasty ones like that. I'll pause while you figure this one out. This one is not a nasty one. Okay, here's how you should have approached this one. The 5 comes out, y equals 5, and then x squared plus 4x, and then I'm going to leave room and put the -2 at the very end. Then half and square. Half of 4 is 2. 2 squared is 4, and -4. Don't forget the 5. Then, final answer, 5x plus 2 squared, -20 minus 2, -22. Raise your hand if that was perfect for you. Okay, good. Now, how about if we have a fraction? When you factor out the 5, now, you're going to have this. Why is this tough? Because you have to do half and square on a 1. What's half of 1? It's a half. And then you square it. It's not that bad. Go ahead. Finish it off. Some people just die when there's a fraction involved. We've practiced them enough. You guys should really, actually, you should be much better at it than you were at the beginning of the year because we did all those top 20s. So fractions shouldn't scare you that much. 1/2 squared. Could you put it like that? Absolutely. You don't even have to really square it. But squaring it's not that hard. 1/2 times 1/2 is 1/4. So if you want to put 1/4 out here, that'd be fine. Then this 5, gotta not forget the 5. It's really easy to do. Final answer, 5x plus a half. That's why it's actually good to say 1/2 squared instead of 1/4, because then it reminds you that this is actually a half. And then 5 times the 4th is 5/4 minus 1. Don't be afraid of these now. What's the 1 really in fourths? How many fourths is that? 4/4. Right? 4/4, same thing as 1, right? So now 5/4 minus 4/4 is just 1/4. So 5x plus a half squared plus 1/4. That was 1/2 squared, but whenever you do this, you always are putting in the square root of this number. So we use the 1/2 on purpose. Question? It was negative. Why isn't it still? You're right. Thank you for catching me on that. There's supposed to be a negative right there. I forgot because when I was putting in this, I was supposed to put negative that right here. So that should be -1/4 times 5 would be -5/4. -5/4 minus 4 will be -9/4. Thank you very much for catching that, because the video today is going to be shown in a lot of classes. So -9/4. It's easy to screw up those fractions. It is. They're not really hard. It's just it's easy to forget something like that, like a negative. All right. And can you leave it as 9/4? Absolutely. If you wanted to make that 2 1/4, that'd be okay, but it's actually better to just leave it as 9/4 because then you won't mess up when you're trying to simplify it. All right, notice these other little questions. On the test, you will be asked these types of questions. What is the vertex now? Well, let's just pluck this and this out of here, right? Almost. What do I do to that one? Opposite. So it's going to be -1/2 comma -9/4. Next thing, is it a max or a min? All normal parabolas will have minimums, unless they've been flipped over. How would you tell if it's been flipped? You look in the front and see if there's a negative. There's no negative here. It's just an equal sign. So there's no negative, so it's a right side up parabola. Another thing I could do is actually figure out where is this parabola. It is at a vertex of negative a half, comma negative 9/4. So it's like that. There's my vertex. And it's a parabola going like this. Now tell me, once you got a little picture of it, it's easy. Is that a max or is that a min? That's a min. Maybe make yourself a little sketch when you're asked that question. That way you won't mess it up. If there had been a negative in front of the whole thing, this thing would be upside down like that, and then it'll obviously be maximum. But okay. Domain. This is one of those rare always times. The domain of a parabola is always negative infinity to positive infinity. This answer is unlimited. Why? Because domain is going this way to this way. Do you get how it's going to go forever in both directions if we extend the graph? All right. And then the range is the low to the high. What's the lowest this will ever go compared to what's the highest it'll ever go? The lowest it'll ever go is that y number. That's how far down I was going. Negative 9/4 to infinity. And I'm going to purposely make a mistake here. What mistake did I just make? Bracket. Very good. Because it touches negative 9/4 right here. And so if it touches the spot, you're supposed to have a bracket on it. Negative 9/4 to infinity. Right. That's what you need to know about this type of problem. Let's see if you can do one all completely by yourself. I don't think you'd have been able to do this when you walked in. But after practicing a little bit, I bet you can do it now. I'll pause for a second, try to answer every part. There will be a fraction in the answer just like there was last time. Okay, I'll pause. Okay, so here's how it should have gone. You factor out the 6. Then you got x squared plus 3x. And then I'm moving this minus 1 over, so I got room. Actually, I should move it even further. Way down. Then, a little room for half and square to happen. Half of 3 is, I'm going to call it 3 halves. Plus, and then last time I forgot it was minus, so I'm putting a minus out there right away. 3 halves. And I'm going to square it, don't worry. And then I got to be careful where I square it. This part is squared, and the negative does not get included in the squaring. That's important to understand. It's squared first, and then you make one positive, one negative. All right, now I got to multiply that whole thing by 6. Because this 6 here has to have one there to counteract it. Okay, and now I think I'm down to the final part. 6x plus 3 halves squared. And then 6, okay, we've got to do this in the right order now. That's going to be 9/4, and then I make it negative. So it's negative 9/4, but that has to be times by 6. And now let's see if I can not mess this up. 54 over 4? Negative 54 over 4? You know, I could do some canceling. That might be smart. No calcs. You're going to have to be able to handle multiplying. This is a particularly tough one, but you have to be able to handle multiplying fractions and stuff. It's part of the deal. You're moved up to the big time now. You're in honors, higher algebra. So 27 over 2, and it's negative. So negative 27 over 2, and then don't forget the minus 1. Negative 27 over 2, and then I take away 1 from that. Can't do that because I need common denominators. So that's going to be 2 over 2. And now, final answer, negative 29 over 2. We're not multiplying those, we're adding those, so the denominator just stays the same. So final answer, y equals 6x plus 3 halves squared minus 29 over 2. That is as tough as any problem would ever be on the test, especially that last part, that negative 29 over 2 part. That's tough, I know. How many of you actually got it without me? All right, we're about 7 of you, and that's about right. About 1/3 of the kids were able to do this by themselves. All right, and now what's the final answers? Though the vertex, that's easy. It's just this and this. Don't forget to put a negative on that when you say that's the vertex. Next is it a max or a min? As long as there's no negative in front, it'll always be a minimum. Next one, domain, always from negative infinity to positive infinity. And then the range, it's from how low to how high. That tells you right there how low it'll go, because that's the y-intercept. No, wait. No, it's not. It's the y of the vertex. So it's the lowest spot. So it goes from negative 29 over 2 to infinity, because it's going upwards It's a bracket on that first number. All right, that's the hardest, no doubt. That's tough, and especially coming off 21 days and no math, I get how that would be hard for you. You'll only have one problem like that tonight for homework. How do you get the solutions, the roots, the zeros? This one's quadratic formula. Or there's something faster, the quadratic formula. What do you do? Factor it. Everybody factor that thing. And then you'll see the answers just jumping right out at you once you've got it factored. Go ahead, factor that. I'll pause for a moment while you factor it. All right, so this one, it factors into an x, and that multiplies to x squared. And then something has to multiply to 5 and add to 6. And that's going to be what multiplies to 5 and adds to 6, a 5 and a 1. And this is a plus and a plus. So final answers are x equals -5 and x equals -1. There's my two answers. Raise your hand if you had those right. All right, good. That's a basic one. You got to know how to do that. If it won't factor, what are you going to do? Quadratic formula. You stick that into the quadratic formula. I was asked a question about how do you do that harder kind of factoring where it's like, let me see for a second here, where it's got a lead coefficient that's not 1. Problems like 2x squared minus 7x minus 4. If you had to factor this one, I taught you a new way of factoring it that I've been asked to remind you about. Yes, you can definitely just guess and check. 2x and x is how you'd start. And then you can guess and check until you find the answer. But there was that other way. Do you remember how that worked? You take the a and the c term, that, and you multiply them, and that makes -8. And you ask yourself, how could I make a -8x with this guy? And you say 2x squared, and how do I make -7, and then I got to break that up somehow so that it would add up to -8. Remember how to do that? -7x and what? If I do this, that's not the same thing though. I have to somehow make it the same. Pause for a second. Okay, so we figured it out. If that's a -8x and that's a +1x, then the total will be -7x and it would multiply to -8x. Okay, good. So this is just a different way of factoring. You do not have to do it this way. But if you wanted to continue from there, you'd take the 2 out and you'd have x squared, no, 2x out, sorry. And you'd have x minus 4. And then over here, you'd take out the 1 and you'd have x minus 4. And then, you know, that's one of your answers. X minus 4. And then the other part of your answer is this, 2x plus 1. Personally, I still think I like guess and check better. But either way, you have to be able to factor those kinds of things. Yes. All right, so that was starting with this and factoring it into that. Why do we factor things? So we can set them equal to 0 and then use the zero product property, it's called. So I get two answers, 4 and then -1/2. 2 times -1/2 would make -1 plus 1 makes 0. So and putting a 4 in here makes that equal 0. All right, so moving on. This one. Solve for x. This time, I'd like you to use the quadratic formula. Everybody, please recall that. Dust it off out of your memory. X equals -b plus or minus the square root of b squared minus 4ac. Stick the numbers into the quadratic formula and tell me what you get. I'm going to pause for a moment while you use the quadratic formula. You will have to use the quadratic formula on this test. Not all of them are going to factor. All right, here's how this one goes. You can use the quadratic formula for this one. X equals -b, -4, plus or minus the square root of b squared, 16, minus 4ac. And if there's mistakes, I bet you, of all the people listening, some of you people made mistakes, and I bet you made them in here. So be careful inside the parentheses, or sorry, inside the square root. All over 2a, 2 million times negative 1 makes negative 2. So final x equals negative 4 plus or minus the square root of, negative 4 times negative 1 times 12 is 48. 48, and there's two negatives in here, makes it plus 16. 16 plus 48 is 64, and that's a key. Because then you go, oh, square root of 64, I know that. That's just 8. So then you have to do the problem twice, once with the plus, once with the minus. Final answer is x equals negative 4 plus the 8 over negative 2, which comes out to 4 over negative 2, which comes out to negative 2. And the other side of the answer is x equals negative 4 minus 8 all over negative 2. And that makes negative 12 over negative 2, and the negatives cancel, makes it 12 over 2, which makes it 6. Negative 2 and 6. Raise your hand if you had those right. That's 3/4 of the class. All right, good. Question. Could you have factored out the negative 2? Yes, but your answers should have stuck them out the same. The final answer is negative 2 and 6. I know what you're thinking is, could you simplify it? That's actually the very last thing that we're going to do is that kind, where you simplify them. Take a look. See what I'm doing here? On that kind, you're going to have to do the cancel of 1 and everything. But you didn't need to on that other problem because they were all nice whole numbers. All right, this one. How do you get the roots? Only thing different on this one? How do I start? Move the 12. Then it's set equal to 0. Is that important? Oh yeah, you can't do them unless they're set equal to 0. And then you go plus 12. And then you could either factor that, which is kind of a pain because there's a negative in the front, or you could, in fact, it's the exact same problem as last time. It's the one, so we already got the answers for that. It was 6 and negative 2. So there we go. Only difference, you got to start by getting it equal to 0 first. So watch out for that. Okay, next thing. What is the discriminant and what does it tell you? It's b squared minus 4ac. And b squared minus 4ac is found in that big long formula, not y equals x equals negative b plus or minus square root b squared minus 4ac. Notice right there, that's it. All over 2a. That part's the discriminant. And if that part's positive, it's all good and you're going to get two answers. If that part's negative, you have a negative underneath the square root and then it'll crash and then there's no answers. If that part's 0, then plus and minus 0 is kind of irrelevant, right? So this whole thing cancels if this is equal to 0. If it's equal to 0, there is an answer and it's this. If there is an answer, it's one answer and that answer is the vertex. Why is it the vertex? Because this formula right here, that's the formula for the vertex. Oh, lots to remember. All right, so what you need to know about discriminant is there's 3 cases. If it comes out positive, then there's 2 answers. If it comes out negative, there's no answers. And why? Because if you have a negative right at the square root. If it comes out to 0, you will have one answer, and it's the what? Vertex. So if your discriminant, which is b squared minus 4ac, comes out positive, you get this. If it comes out negative, you get that. And if it comes out 0, there's only one answer, and it's the vertex. All right, so what is the discriminant again? The discriminant is b squared minus 4ac. So there's b. So what's b squared? 36. Minus 4ac. What's a? What's c? So then it's really 36 minus 4 times 11 is 44. 36 minus 44. Wait a minute, that's a negative. I don't even care what the answer is. Because if it comes out negative, I know there's how many answers? There's 0 real answers. So the discriminant is going to tell me that there's no answers. But I really should finish it. The actual answer, when I subtract 44 from 36, it's like 44 minus 36 this way. It's just going to have a negative answer. And let's see, I got to subtract here, so that's too big. So I got to borrow some from the 4 and make it a 3, and that's a 14. 14 minus 6 is 8, and then 8. It's just 8? All right, so final answer, negative 8 is my discriminant. What does it tell me? It tells me that there's no real answers. It's imaginary answers, but no real ones. All right, so that's a typical discriminant question. Now, the last thing we have is quadratic formula simplifying. We did this on the top 20 sheet, so you guys are already good at it. So that square root of 18 is where you start. Tell me, what are the two roots you'd make that into? Root 9, root 2, which makes it really what? 3 root 2. Good. Once that's turned into 3 root 2, you'll notice that there's a 3 in everything. Go ahead, simplify it down. Write down your final answer. Billboard it to me. And I'll check them off real quick. You disappeared the first number. You don't want to do that. Yes, it only goes in there once, but there's a 1 left over. Don't make that front number disappear. Good. Good. Zoom in on it a little closer. It's too small. Good. Good. Yup. 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 Denominator got funny for some reason. Yup. 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 All right, good. So what went into everything? Somebody had a negative wrong, so watch. I just noticed it, but I don't want to call them out on it. What goes into this 3? Well, everything. 3 goes into everything. 3 goes in here once. 3 goes in here twice. And 3 goes in there once. Final answer, -1 plus or minus the square root of 2 all over 2. Make sense? All right. And there's just another problem like that, but I think you get the idea on these well enough. Wait, I'm going to skip that one. So, all right, now your homework. I'm going to suggest that you only do part of the homework tonight, and then you're going to finish it for tomorrow so that it's really due Friday. But here's the part I want you to do tonight. Question first, though?
If you were to divide by -3, would you do 1 plus or minus whatever over -2?
Okay, if you want to see if -3 goes into everything, then I would say -3 goes into here 1 time. -3 goes into here -1 time. And -3 goes into there -2 times. And yes, that would actually end up being the same thing. I change every sign. Make that +1, make that a -1, make that a -2, and you'd end up getting the same exact answer. All right. But this is the main thing before. When that disappeared, that wasn't good. That 1 has to be there. All right. Okay. So now, your assignment for today. Since it's in ABCDs, I can't say just do the evens or do the odds. So here's the ones I want you to do. Everybody open up the assignment, and then I'll tell you which ones to cross off. These are actually going to be done tomorrow, whatever gets crossed off. Here's the part I want you to do for today. Do 1A, 1C, problem 2, which is to go back on 1A and 1C and to graph them. Number 3A, 3C, and 3E, and 3G. Then you're going to do 4A, 4C, and 5A, 5C, and 5E. So pretty much I'm having you do the evens if there were such a thing. It's just that they're all ABCDs. Okay? So those are what I want you to do. Do these for tomorrow. And then you're going to do the other ones for Friday. So this is dividing it into 2 parts. Okay, so effectively, how many questions? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 questions. Yes, there's even some little bit of multi-parts within those, but that's a doable assignment for tonight. I'm really glad we didn't try to teach all of this and then have all of this for your assignment for tonight and then have the test tomorrow. That would have been rushing it pretty hard, so it's working out pretty well. Thank you, Dr. Peterson. All right, any last questions? Okay, the rest of the time is your work time.